Hello 8th graders, in this IXL video we're going to be taking a look at IXL assignment R5, which is on Pythagorean theorem. And I like this one the most because this one's about word problems. It's about actually being able to use this Pythagorean theorem in the real world to figure out some missing information in some real world problem. You all might find these annoying because they don't give you a picture of a triangle right away. They're going to make you think through these word problems or see a triangle in a picture already. And as you're going to see when I go through here, my job is to really visualize this word problem, draw out the scenario, and then the Pythagorean theorem should be pretty easy if you've already done R1 through R4. So here, I'm going to read through this together and show you how my brain does these word problems. It says, from a train station, one train heads north and another heads east. So I'm going to put a little dot here, and I'm going to call that my train station as I'm thinking through this problem. We're at a train station there. And it says one train heads north. I'm going to switch my color to make it easier to talk through with y'all. It says one train heads north. And I'm going to call that the blue train. And it says one train heads east. And I'm going to call that the green train, I guess. And north I know is up. East I know from a map is off to the right, but you could do left or right. Doesn't matter a ton. And then it says, sometime later, the northbound train has traveled 12 miles. So I'm going to go ahead back to my blue color, and I'm going to label that northbound as 12 miles. It goes 12 miles up there. I'm just going to call it 12 for now, just so that miles isn't in the way. But it goes 12 miles up. And it says, if the two trains are separated by a straight line distance of 20 miles, how far has the eastbound train traveled? And so this question, how far has the eastbound train gone, that's in green here, if these two trains are now 20 miles apart? And what you need to realize here, that 20 miles, which I'm going to put, I guess, purple around, if the straight line distance between the two trains is 20 miles, that means from this train to where that train got, we have 20 miles there. And my question is, how far did that other train, the eastbound train, go? So hopefully some of you are seeing here a right triangle. And you're saying, hey, Mr. Doherty, I'm going to put this all into black color here. The 20 is our C. The 12 is our A or B. It's one of the legs. And the other train, the eastbound train in green here, that's B. We've created a right triangle here. And all I'm going to need to do is do 20 squared minus 12 squared equals b squared. And this writing's going to be a little small. I made my picture too big, and I'm just going to write my equation as best as I can. But I know the big side, c. I know a as well, and I want to find what b squared is. And then I'm going to take that formula there, that c squared minus a squared equals b squared. Sorry, this is taking me a second. And I'm going to just plug in the 20 for C. And I'm going to plug in the 12 for A. And then once I've done that, 20 squared minus 12 squared, I'm just going to do the math. And this should be the familiar part for you all now. 20 squared is 400. 12 squared is 144. This is what you've been doing in R1, R2, R3, and R4. And then when we subtract those two things, 400 minus 144, we are left with 256. Equal to b squared. And then I'll show the last step in pink here, because this is the important last step to always remember. Oh, it's in maroon, I guess. I'm going to take the square root of both sides. And I know the square root of 256 is 16. You could put that into your calculator. But 16 times 16 makes 256, so that's why the square root of 256 will spit out as 16. Before I write that answer, I'm going to put it here. And yeah, that does seem reasonable. 12 and 16 and a 20-mile hypotenuse seems pretty good. So I plug in that 16. Now we've got another problem. Let me clean up the screen a little bit, and let me emphasize again, this whole R5 assignment, if they're not going to give you any pictures of triangles, is about drawing out the scenario or the story yourself so you can see the triangle. They say the floor of a rectangular living room is 12 meters by 9 meters. So I'm going to draw a little rectangle right here and try to make it 12 by 9, kind of estimating. We know the living room is 12 meters by 9 meters. So I'm going to go ahead, that's dimensions is linked by width whenever you give a room's dimensions. So I've got 12 meters at the bottom here, and I'm also going to call this 9 meters up there for our rectangle. Now, the question asks us, and we'll highlight this in red here, I believe. It says, what is the distance between opposite corners of this living room? So our living room's 12 by 9, but they want to know, hey, what is the distance between one corner to the other? And this is a great word problem, important to point out. Whenever you have rectangles or squares and somebody says, what is the diagonal distance? It's actually a Pythagorean theorem problem to find the diagonal. I see a right triangle here. I see that right triangle. Let me try to find a different color marker. We'll call it blue. I'm tracing in blue this right triangle that I can kind of see here. And everyone see that right triangle that's sitting there that I'm outlining in blue? That's what we're going to work with. And we know that it is 9 meters, and I'll take this 12 meters here, put it up there, by 12 meters as we look at this one. And our question is, in blue again, what is this longer side here? We used to have it in red. Now I'm putting a blue line over it for a second. What is this longer side? And hopefully you're saying, Mr. Doherty, that's just the C. That's the longest side of a right triangle that has legs of 12 and 9. And I'd say you're totally correct. And then you'd say, well, Mr. Doherty, if that's the case, if we know the two legs, then we need our a squared plus b squared formula. We know the two legs, the two shorter sides that form the right angle. We want to know the hypotenuse, the longer side. So I simply use a squared plus b squared equals c squared. That formula you see there. Would plug in the 12 and the 9, but I remember the 3, 4, 5 triangle. I see that these were multiplied by 3. I know c is going to be 15 before I do any of this math out. And in the interest of time, I'd say you could plug in 9 and 12 here, but you'd eventually find c is 15 because it's just a 3, 4, 5 triangle multiplied by 5. So you can do that math out. I think y'all are great to find that if this is the 3, 4, 5 triangle, your math is going to find that that missing side C is 15 meters long. Now at this point, you've got what you need for R5. R5 is annoying. It makes you think more as a word problem, but if you draw out the picture and you get your triangle, you know how to find the missing side of a right triangle by the time you've made it to R5. If you still can't find missing sides of a right triangle, go back to my videos for R3 or R4, which help you practice that. I'm going to jump ahead to show one final problem. Just to see if they get more difficult, but you see they don't get more difficult. There's still a word problem that describes some triangle in the real world, and they just give you more annoying decimal numbers. So I'm actually not going to show this last video. I thought they were going to make it more difficult for word problems and maybe give you a 3D picture. But they just keep describing flat 2D triangle scenarios in the real world where you need to draw the picture and the numbers might get more difficult as you go. But you've already done that in the R3 and R4 world. So if you do have trouble towards the end of R5, you are always welcome to send me an email, a G-chat. I'm ddoherty3@bostonpublicschools.org. But I do believe at this point you all are in very good shape to draw out your triangles from these word problems, find their missing side, and answer the whole problem. Thanks again for watching to the end of the video. Thank you for your strong work on Pythagorean theorem.